Hi, welcome to my second video in which I explain how I'm using GitHub to distribute my Python packages. In the previous video, I explained how to create a folder structure for a basic project, how to configure tests for PyTest, how to run them with Visual Studio Code, and how to prepare a basic set of files that allows to create a distribution package for this library. So something I didn't show in the previous video, but I'm going to show right now, is that having a setup file like this one, you can start installing this package from your local file system. So let me open a new instance of my Windows terminal, which is opening Ubuntu. I will go to a temporary folder I got here. I create a Python virtual environment. Then I activate the environment. And I can install, as I said, this package from my local file system. So I will use the E flag, which means development mode. When you install a package in development mode from your local file system, it means that the installed package will be linked to this virtual environment, and you can modify the code in the project you are installing, and it will be automatically available in the second virtual environment. This is convenient when you need to debug some code that needs to happen to live in a dedicated package. So let's say I will add the path to the full project, this one. It says successfully installed foo demo 2. The name foo demo 2 and the version are configured here in the setup file. And once this is done, I can launch Python and import my function. You see, this is the function I defined here. But now let's do something more interesting. Let's add GitHub workflows. To do so, I will need to create a folder named .github. So let's do it from here. Negative.github. And inside GitHub folder, I was saying, oops, this one, I will create a folder workflows. And inside workflows, I will add a YAML file, which I'm going to copy from one of my existing projects, and I'm going to describe. I always copy one that is working, because as you can see, it doesn't make sense often to rewrite everything when you know that some actions are needed. I'm going to explain what they do. So new file, we call it main.yaml. And what do I have in a basic project like this one? I configure a name, can be anything you wish. Triggers. In this case, I have for triggers a release. A release is created when you create a release in GitHub. I'm going to show later how to do it. With types published. Push, it means when you are pushing to the specific branches. And pull request, when you receive a pull request. So the env specifies environmental variables, and you can use them to increase reusability of your steps later. In this case, my project name is foo. Then I usually specify jobs. The first job is named build. It runs on Ubuntu. Here you could also write Ubuntu latest if you want to get the latest version available for the agents. And a strategy. The strategy is useful to demonstrate that your project works with different versions of Python, because you can run the test in different versions of Python. Of course, you can also have the strategy running on different operating systems, which is convenient. For example, if you work on a Python extension in Python that needs to be compiled in different for different operating systems. But in this case, I'm writing pure Python code that will work out of the box in various operating systems. So this is sufficient. The first step, each job has various steps. The first step is to do checkout of the code. Then I'm using Python of the version of the matrix. So only transfer 3.7, it will be 3.7, for example. And by the way, let's remove 3.6. Let's add 3.10, which is the latest one. Then I have an action to use the dependencies cache. In this case, you see it is hashing a requirements.txt file, which I didn't create yet, but I'm going to do right after explaining the workflow file. Then this is convenient to make your jobs more efficient. It is downloading the dependencies if the previous step didn't have already dependencies on the local file system. So it is using the command pip download with a destination folder and for the requirements file. Install dependencies. It will install the dependencies from the downloaded libraries in the depths folder. And then you can run tests using PyTest. In this case, I'm also generating code coverage reports, but in XML, because they can then be uploaded to tools that do analysis of the code coverage. In this case, in my project, I'm using CodeCov, but I'm not going to show this because it would be too many topics in the same video, so I'm going to remove this one. Then I have linters. I'm running linters to verify that the code is properly formatted with black and high sort and doesn't have any issues regarding code quality according to the configuration of flag 8. Then I'm uploading test results as artifacts of the build. And here I'm preparing a distribution package. So first I'm installing some additional tools that are necessary to create the distribution package. You see, in this case, I'm doing it only for a specific Python version because the code I wrote here, it doesn't require compilation, as I said, because it's pure Python that should work on different operating systems out of the box. So of course, you can, if you wish, do prepare distribution packages for anyway for different versions of Python. But if in this example, I will keep this one, and it will work. So this is the command to create a distribution package, which means it's building also wheels. And I'm uploading the distribution package as an artifact of this job. Then I declare a second job, which is named publish. It needs the build job, which is the one I just described. I have a condition that this thing happens only upon release. And the steps are downloading this distribution package that was published here and publishing it first to test PyPi and to the production PyPi. These two steps require secrets, and I'm going to show later how I'm configuring them in my GitHub repository, in my GitHub project. However, to not keep everything in the same video, I'm going to show this part in a third video. So let's start by committing these things, including the workflow, and pushing it to the remote repository. Once I push it, thanks to this trigger, you will see that an action will start immediately to run the build. So the build will run the test and verify that the code I'm pushing is working. So now let's push the code to GitHub. You see now, yeah, Visual Studio Code folder still not ignored. So I will add it to my git ignore file. Yes, I can do git add dot and verify that I staged the things I want to push. So there is the workflow file, change it to the git ignore, make file, foo init, it's everything. So we'll do git commit shell structure. And as I said, since I'm already pushing the workflow file with the trigger for the main branch, it will start immediately. Let's take a look in on the portal. We see here this orange dot. It means that an action is running for this commit. And the action has the 4 builds I described earlier for the matrix 3.7, 3.8, 9, and 10. Let's go to the actions, initial structure, and it failed. Let's see why it failed. It failed because I forgot to add the requirements file, which I said I would create before the pushing. But let's add it. I go here and I pick please requirements.txt. By the way, let's take a look. So you have the things I installed earlier: Black, isort, Flake8, PyTest, plus their dependencies. And since we are here, let's also check if the linters will be happy about my code. Something I didn't describe yet, this part of the build around linters is using Flake8 to check the code quality, and isort with check only flag, and Black with the check flag to see if the code is formatted properly. So let's see with Black. It's fine. Isort. Okay. And Flake8. Flake8 dot doesn't work well right now because it's not ignoring the virtual environment. So let's change this line to be Flake8 full and Flake8 test. You could also create a Flake8 configuration file to ignore the virtual environment. Let's do it. I will copy one from this project. You see that I have exclude virtual environment. I will copy this. And that's fine. Now if I do Flake8 dot, it should run quickly because I excluded the virtual environment. And so let's also go back here and let's put again the dot. So it's good that I decided to run them before running the GitHub Actions. So let's see what I think. I only added this file. And that's it. So a new action started. Right now I showed this kind of triggers. One that I also often use is the workflow dispatch. Without any input is fine. Workflow dispatch enables running the workflow manually when you need to do it. Right now, I've been pushing directly to the main branch because I was creating the project structure, but in a second, I will show how to configure branch rules so that you cannot, or at least that you, when you expect contributors to create pull requests, I say expect contributors because you could configure administrators with rights to push directly to the main branch, right? So now it is running. It completed already for Python 3.8. It ran the test, the linters, everything was fine. And you see now they are completing. One thing I recommend is to configure the fail fast property in the testing strategy to false, because if the test were failing only in Python 3.10 because of some incompatibility, then you would still want to see what happens with the other versions of Python. So let's go here to the workflow file, and in the strategy, I usually add fail fast to false. It's convenient when you, as I said, when you want to verify that things work in different versions of Python if they fail because of incompatibility reasons. Linters also ran, they're happy. And let me go configure a branch rule for the main branch. So I go to settings, code and automation branches. Let me increase also my size here. So I went to settings, code and automation, and I will add branch protection rule. Branch name pattern I will write main, and I will tell require status checks to pass before merging. And I will select the builds I just executed. Bear in mind that as far as I know, you cannot configure these things until you have the runs 3.9. So you need to run once the actions, as far as I know, before you can configure these things. If somebody knows better, please correct me in the comments of the video. There are also other options. You can require a linear history, signed commits, whatever you wish here. So in general, for my projects, this is the first thing I want to enable, and that's it. So now what happens? I created a branch policy, and let's see what happens if I break my code in a branch and I push the code in a branch and then create a pull request. I will go here. I will create git -b. I will say broken. So I created a branch named broken. And here I will go to my test and I will change it full function to return full x. So this test will fail. Let me commit this code anyway and push it and see what happens when I create a pull request. I will also add the changes to the workflow files. Break the code. And here, quite conveniently, I have link to create a new pull request. I will create a pull request. And now, thanks to the branch rule I created, I have these checks happening. They will fail, of course, so I will get red everything here. And then I can fix the code push again and merge the merge the pull request because of these changes to the workflow file. Yeah, it failed. So let's fix it. I know you can do it in a single command, add and commit, but I'm so used to do add and commit that, and I often run the status before committing to be sure that I'm not breaking anything. So I'm used to do it to do it this way. So now I pushed and the build will start automatically. This is also something nice. I have an active pull request and you can see the build started automatically. When somebody else is trying to contribute to your projects, you will need to approve the runs. You can see in this case, the only file that changed now is the workflow file, so it's okay. Yes, so now it completed. I go back to my pull request and I will squash it. I like to squash and merge. And then I will delete the branch. So now we go back to the main branch and I don't like to write all the time git checkout main, git pull origin main, so I have shortcuts in my bash to write just git main, git pull, git push. But this is another topic. I'm not going to speak about this right now. I mean, I'm not going to show how I'm doing that. So for this video is everything. I wanted to show how to install a package from the local file system thanks to the setup file. I want to show how to run actions. In the next video, I'm going to show how to publish the package into the Python package index and how to do it automatically on release in GitHub. So thank you for listening and have a nice day.